Scotland, where misty highlands meet centuries of legend, and every drop of rain might just become something extraordinary. When you picture Scotland, you might see kilts swirling in the wind, the haunting call of bagpipes echoing across the glens, and landscapes that look as if they've been painted by history itself. But there's another Scottish icon, one that bridges the gap between ancient craft and modern science. A golden liquid, revered worldwide, crafted with both heart and a dash of chemistry. Yes, I'm talking about whiskey, or as the Scots call it, Whisky Beatha, the water of life, born from both tradition and innovation. It's more than a drink, it's a symbol of national pride, a global export, and a testament to Scottish ingenuity. For centuries, Scots have transformed humble barley, pure water, and a sprinkle of yeast into something magical, thanks to a little help from science. It's a process steeped in tradition, passed down through generations of master distillers. But here's the twist. Behind every legendary dram is a story of scientific discovery. Beneath the romance and misty-eyed nostalgia, there's a world of ingenious engineering. It's an industrial marvel, a symphony of chemistry, physics, and mechanical know-how, all working in harmony. Scotch whisky's global reputation isn't just luck or good water, though that certainly helps. It's built on a deep, intuitive, and now scientific understanding of a complex craft. From the design of the grain mills to the shape of the copper stills, every detail is engineered for a reason, blending tradition with precision and always chasing that perfect, repeatable result. The story of whiskey is a tale of transformation, where ancient craft meets modern science. It all begins with a humble grain, malted barley. Traditional malting lets barley germinate just as it has for centuries, yet today, every stage is monitored with precision. The germination is stopped by kiln drying. Here, peat smoke can be introduced, infusing the grain with its signature aroma, now measured and controlled for consistency. If peat is used, smoky phenols cling to the barley. Today, chemists can analyze these compounds to ensure the perfect balance of flavor. The result? Distinctive, complex notes, medicinal, smoky, and wonderfully layered, crafted by both tradition and technology. The peated malt is milled into a coarse flour called grist, using time-honored mills, now often equipped with sensors for quality control. Every step is mechanical and precise, like preparing ingredients for a complex recipe, with each variable tracked and logged. The grist is mixed with hot water in a giant mash tun, where temperature and timing are now controlled to the degree. Thermal engineering comes into play. Water is added in carefully staged increments, each monitored by sensors and computers. Enzymes from malting convert starch into fermentable sugars, a process now understood and optimized by biochemists. The result is a sugar-rich liquid called wort. Imagine industrial porridge, tested in the lab for just the right sweetness. The mash tun itself is a marvel. Copper domes and rotating rakes, now often automated for efficiency. The wort is drained, cooled through heat exchangers, and pumped into washbacks, each step tracked by process engineers. Washbacks can be made of traditional Oregon pine or modern stainless steel, each material chosen for its unique impact on fermentation, and both monitored for hygiene and performance. Yeast is added, and fermentation begins, a lively biological process, now tracked with sensors and lab tests. Yeast feasts on sugars, creating alcohol and CO2, monitored for optimal yield and flavor, bubbly, frothy, vigorous. The result is wash, a strong beer-like liquid, its strength and purity checked by both taste and technology. Wood versus steel can influence flavor. Wooden tanks may harbor bacteria, adding complexity, now studied and managed by microbiologists. Every stage, from malting to fermentation, is a dance of biology, chemistry, and engineering, guided by tradition, perfected by science. Step inside the Stillhouse, the very heart of the distillery. Here, centuries-old copper pot stills stand as monuments to tradition, yet every drop they produce is shaped by the laws of science. This is where ancient craft meets modern chemistry. The magic of whiskey is really the magic of molecules, thermodynamics in action. The wash, our fermented barley brew, is pumped into the first of two copper pot stills known as the wash still. Its shape, unchanged for generations, is key to the process. Distillation is all about separating substances by their boiling points. Here, tradition relies on the precision of physics. It's all about thermodynamics, energy, heat, and transformation. Alcohol, specifically ethanol, boils at about 78 degrees Celsius, well before water does. Water, on the other hand, boils at 100 degrees. This difference is the secret to distillation. As the wash is gently heated, alcohol vaporizes first, rising up through the still while water lags behind. A beautiful demonstration of phase change. Imagine two runners in a race. The alcohol gets a head start, rising as vapor while the water stays behind. The alcohol-rich vapor travels up the still and into the neck, guided by the very shape crafted by generations past. The shape of the still isn't just for show, it determines how the spirit develops. A tall, slender neck increases reflux. Heavier vapors condense and fall back, creating a lighter, more delicate spirit. That's how you get those elegant floral notes in some whiskies. A shorter, fatter still lets more heavy, oily compounds carry over, resulting in a richer, more robust spirit. Every distillery guards its still shape, the geometric DNA of their whiskey. It's a blend of art and science, passed down and perfected. Next, the vapor moves into the condenser, where it cools and returns to liquid form thanks to another clever bit of engineering. The condenser is a massive heat exchanger, swapping heat between vapor and cold water. Hot alcoholic vapor flows through copper tubes, surrounded by cold water. Science and tradition, side by side. Like a radiator working in reverse, it cools the vapor into precious liquid. The cold water pulls heat from the vapor, which condenses into liquid. Low wines, around 20 to 25% alcohol. This new liquid is concentrated, but the journey isn't over yet. It's a perfect example of how tradition and scientific precision work together in every batch. Heating, vaporizing, condensing, classic phase change heat transfer, applied not just in textbooks, but in the creation of Scotland's liquid gold. Picture a distillery as a living, breathing organism, its lifeblood flowing through a maze of pipes, pumps, and vessels. Here, tradition and technology pulse side by side. Guiding the movement of water, wort, wash, and spirit is both an art and a science. Fluid mechanics in action, shaped by generations of hands and minds. Every drop must reach the right place, at the right time, with the right temperature and flow. Precision engineering meets the intuition of the master distiller. It all begins with the water, drawn from local springs or lochs, piped straight into the heart of the distillery. The purity and character of this water are absolutely vital, shaping the whiskey from the very start. In the mash tun, hot water is delivered with exacting care, volumes and temperatures measured to the degree, blending tradition with modern control. Pumps, valves, and heat exchangers, each a crucial organ in this living system. The wort, thick and sweet, is swiftly cooled, sometimes in old wooden washbacks, sometimes in gleaming plate heat exchangers. Rapid cooling stops unwanted bacteria, a perfect example of how science protects the art. Pumps must be powerful, yet gentle, preserving delicate flavors as they move the liquid along. After fermentation, the wash is carefully pumped from traditional washbacks to the waiting stills. The wash is slightly acidic and full of solids, so every pipe and pump must resist corrosion. Modern materials meet age-old needs. Low wines, the next stage, are transferred with the same care. Each movement a blend of tradition and technical know-how. After the second distillation, the heart of the spirit is pumped to a receiver, ready for casking and maturation. All this movement is orchestrated by a web of copper and stainless steel, old-world beauty and modern efficiency intertwined. A walk through a distillery is a tour of industrial artistry, valves, gauges, and junctions everywhere you look. Even waste has its own pathways. Hot, acidic pot ale and spent lees are managed with care and precision. Modern treatment plants turn waste into animal feed or biogas, engineering that closes the loop. From the intake of pure water to the output of spirit and byproducts, the distillery is a masterclass in fluid handling, where every detail matters. Every pipe, pump, and valve plays its part in this grand, ever-evolving ballet of liquid and engineering. Picture the classic distiller, hands stained with copper, eyes sharp from years of experience, guiding the spirit with intuition and skill. But today, the story continues. Modern distilleries blend this hands-on expertise with cutting-edge technology. Automation is the latest chapter in this tale, not replacing the distiller, but giving them new tools to perfect their craft. Think of it as the master distiller's right hand, precise, tireless, and always ready to help. Nowhere is this partnership clearer than in the control room, where tradition meets technology head-on. Screens and sensors track every detail, like a conductor guiding an orchestra of pipes, pumps, and stills. Distributed control systems and programmable logic controllers are the silent partners, ensuring everything runs smoothly. These digital brains monitor hundreds, sometimes thousands of variables in real time, supporting the distiller's decisions. They track the temperature of water entering the mash tun, the speed of the rakes mixing the grain, the flow of wort to the washbacks, and the precise rate of heat applied to the stills. Automation keeps all these factors in perfect balance, batch after batch. Take the stills, for example. Automated steam valves and temperature sensors ensure the energy input is just right, never too much, never too little. The result? A gentle, consistent boil every time. 4 shots, heart, feints. Automation helps track them all, but the final call is still made by the distiller's expert nose and palate. Sensors measure temperature, flow, and alcohol content, but the wisdom of the master distiller remains at the heart of every decision. Even milling the grain is automated for the perfect grist. Precision meets tradition at every step. Filling and emptying mash tuns and washbacks. Valves and pumps do the heavy lifting, guided by careful programming. Even cleaning cycles are largely automated, ensuring quality and safety without missing a beat. The outcome is a process that's safer, more efficient, and remarkably consistent, batch after batch. Robots and computers haven't taken over. They're simply the most reliable apprentices a distiller could wish for, working hand in hand with human expertise. When you savor a dram of Scotch today, you're tasting the result of an ongoing conversation, one between centuries-old tradition and cutting-edge science. This ancient craft is now shaped by both the wisdom of the past and the precision of modern engineering. Thermodynamics in the still, fluid dynamics in the pipework. These are as much a part of whiskey as the smoky aroma and golden hue. The modern distillery is a fascinating hybrid, the rituals and tools of the past now enhanced by 21st century technology. Iconic copper pot stills, shaped by generations of coppersmiths, are now watched over by digital sensors and data screens, each preserving the character of the spirit while ensuring every batch is just right. Computer algorithms help guide the process, but the heart of whiskey remains in the hands of those who know its secrets. It's a true partnership, old and new, art and science, each making the other stronger, and the whiskey better. Tradition isn't about resisting change. The old ways, refined through centuries of trial and error, gave us the rich diversity of flavors we love in Scotch whiskey. The intuitive skill of a master distiller, someone who knows their equipment by heart, can never be fully replaced by a machine. But modern engineering lets us understand the science behind that art, giving us the tools to repeat perfection, batch after batch. Consistency and quality on a massive scale are now possible, thanks to this union of tradition and technology. The evolution of the distillery is a testament to the spirit of innovation, always moving forward, but never forgetting its roots. Automation, heat recovery, and sustainable practices aren't about changing the soul of whiskey, they're about protecting it for the future. The core process, mashing, fermenting, and double distilling in copper pots, remains sacred. These innovations simply make that process more efficient, more reliable, and far more sustainable. That's how Scotch whiskey will thrive for centuries to come, without ever compromising on the quality that made it legendary. For engineers, whiskey is a playground for practical creativity, a place where tradition and technology meet in every drop. Here, you see the results of your work not just in data, but in the complex, delightful liquid in a glass. The challenges are constant: how to improve efficiency, preserve delicate flavors, and integrate new technology without losing the soul of the process. The story of Scotch is still being written by those who honor the past and embrace the future. And that, I think, is something we can all raise a glass to. Cheers. Don't forget to like, share, and subscribe. ET Muster.